In this section, we're going to talk about quadratic equations, functions, zeros, and models. We're going to find the zeros of the quadratic functions and solve the quadratic equations by using the principle of zero products, by using the principle of square roots, by completing the square, by using the quadratic formula, solve equations that are reducible to quadratics, solve applied problems using quadratic equations. A quadratic equation. So I want to just backtrack just for a second so you understand what's a quadratic equation. We've been solving for lines, like a linear equation. It's a straight line. That means that x plus y or minus y or whatever, the actual equation, they're raised to the first power. It could be x equals the number or y equals, but they're all raised to the first power. So it gives me a straight line, right? Well, quadratic says that the leading coefficient a here has a variable term that has a leading degree of a square, okay? So in order for us to have a quadratic, my leading degree on a equation or function has to be a square. Now, if a is equal to 0, then that means I'm left with bx plus c gives me my straight line. So therefore, a cannot equal 0 in order for us to have a quadratic. B can equal 0. However, if a and b equal 0, then all we have is a point because the only thing we have is c. Our coefficients a and b and constant c are all real numbers, and this here is written in standard form. A quadratic function, okay, a function in this case here is called f in respect to x. We know y is equal to that. Y can be also equal to a function called h in respect of x. Y can be equal to g, and the function's called g of respect to x, and so on. In order for this to be quadratic again, the coefficient on x squared cannot equal 0. Again, a, b, and c in this standard form is all real numbers. The zeros of the quadratic function are solutions of the associated quadratic equation. These solutions are sometimes called roots of the equation. And sometimes we have real numbers, sometimes we have imaginary numbers. Quadratic equations can be real numbers and or imaginary solutions. So a times b can equal 0, and it's a true statement if a or b or both are equal to 0. If I have x squared is equal to k and I'm solving for x, you would want to take the square root of x squared, right? To undo that root and to undo the power. But what I do to one side, I have to do to the other. And since it's an even root, I get a plus or minus, and that's where we come out with two solutions. So now let's do this next example. We're going to find its zeros. In order to find its zeros, we need it written in standard form. So we're going to have ax squared plus or minus bx plus or minus c. It's a sloppy looking c. And you notice my c is over here by itself. So I need to get it on the other side of the equal sign. And since it's a positive 3, I'm going to subtract it from both sides. So now I have 2x squared minus x minus 3 is all equal to 0. I want to show you the full method, or not the full, the AC method on finding the zeros, on factoring it down so we can find the zeros. Now you have that option. You can use trial and error. Some of you may already see the answer, and that's fine too. But let's do the AC method. The AC method says that I'm going to take A times C, where the product of A times C will add or subtract to give me B. What do I know about add or subtract? How do I know we're adding and subtracting? So whenever we're reading a quadratic, we notice that the sign here on C, that sign on C tells me if we're adding or subtracting. okay? And the sign on B tells me what sign we're using. So let's talk just for a minute. We're going to take some extra notes right here. If we're adding, then we know the signs are the same. So if the sign on B is positive, then that means we're going to have a positive plus a positive, right? Some positive number plus a positive number. If the sign on B is negative, then I know I have a negative number plus some negative number. If we're subtracting, the signs are different. Then that means that if the sign on B is negative, that means the larger number is negative plus the smaller number being positive. If the sign on B is positive, then the larger number is positive plus the negative smaller number. Okay, so I'm going to erase this. If you need to pause this to write it down, I encourage you to. This will give me some room. Because we're going to solve for, we're going to factor it, and then we're going to solve for our zeros. All right. All right, let's solve for it. It's written in standard form. So what is A? Well, we know A is 2, B is -1, and C is -3. Ah, what does this tell me? We're going to subtract the product. All right. So let's find the product. So A is 2, C is -3, so I get -6, and we're going to subtract because C is negative, okay? So when I subtract, I know that I got a product of 1 times -6. Well, if I do 1 minus 6, I get -5. No, that's not the one we want. The next product is 2 times -3. So it's 2 minus 3 because the larger number gets the negative sign. We do get -1. So now I have a new middle. So what I'm going to do is come over here and I'm going to bring down the first term. And I'm going to bring down the last term and that equals 0. And I'm going to replace my middle with my new findings. My new findings is a +2. And remember, the middle has an X, so I got to put an X on it. Minus 3X. All right. Now I'm going to split this in half. And I'm going to look at this first side here. And I'm going to ask myself, is there anything I can factor out of this? Well, I have 2x squared plus 2x. I know I can factor out 2x. So when I do that, that's the same as saying I'm going to divide by each part by 2x. So 2 goes into 2 once, and I can pull an x out of x squared, leaving me with x. 2 goes into 2 once, and x goes into x once, and they're both positive, so it's positive. The next thing I need to do now is go look at this other side. I'm going to definitely pull this negative out. It's going to be factored out. But also see a 3 can be factored out both. So I got -3, -3. So negative divides negative is positive. 3 goes into 3 once, leaves me with x. Negative divides negative is positive. 3 goes into 3 once. Now I have 1. All right, so what I want to do now is look at this. I have 2x times that x plus 1 minus 3 times x plus 1 equals 0. What do I see? This parentheses and this parentheses are identical. So that's going to be my GCF. Let's pull that out. So now I have x plus 1. And when I factor that out, I'm left with 2x minus 3 equals 0. Now I'm going to find the real zeros because it's in factored form because 2x minus 3 doesn't factor down no more. X plus 1 doesn't either. So now let's solve. So by doing that, I'm going to take each parentheses, set it equal to 0, and solve. So I have a +1 here. I'm going to subtract it from both sides. So I got x equals -1, excuse me. Over here, I'm going to add the 3 to both sides because I want the 3 to go away on this side here and show up on the other, so I have to make it go to 0. So now I have 2x is equal to 3. I need a +1 coefficient on 2, so on x, so I'm going to divide by 2. So now I have x is equal to 3/2. let's move to the next screen for more room, but we need to check to make sure these solutions are true solutions, okay? Just because I get them doesn't mean they're always a true solution. I got a solution, but we need to check. So in order to check, I'm going to take my answer and plug it back into the original and see if it actually is true. Does it equal this other side? So now I have -1 squared. Well, negative squared becomes positive. So I have 2 times 1. I have negative times negative is positive. So I have 2 times 1 plus 1. 2 plus 1 is 3. Oh, yep. So this is a true solution. Now let's check when x equals 3/2. So now I have 2 x squared. So I'm going to put 3/2 in that place, minus 3/2 is equal to 3. We're checking. All right, so now I'm going to square. I'm going to distribute that square to everything in that parentheses. So 3 squared is 9, 2 squared is 4, minus 3/2. And now I could put the 1 underneath this 2 to notice that it reduces with that 4. 2 goes in itself once, goes into 4 twice. Now I have 9/2 minus 3/2. And whenever we subtract fractions, the denominators have to be the same. And in this case, they are. So I got 9 minus 3 over 2. 9 minus 3 is 6. 2 divides 6 is 3. Ah, perfect. This is also a true solution. All right. You get time, you can go through these slides again. All right. So now let's find x. If you notice, we have 2x squared minus 10 equals 0. There is no b term here. We just have a and c. So this would be easier if I isolate the constant. So if I notice here that this is a -10, I can add it to both sides, making it go to 0 on that one side. Leaves me with 2x squared equals 10. And now I need a +1 coefficient on x squared, so I'm going to divide by the 2. So I'm left with 2x squared is equal to 10 divided by 2 is 5. Now I need x, and it's x squared. So to undo the square, I'm going to take the square root. And that's an even root, so that means I'm going to get a plus or minus on this other side. So now I have x is equal to a positive square root of 5 and a negative square root of 5. Well, let's check to make sure it's true solution. So if I check my work, I'm going to take the original equation and plug in. So I'm going to plug in the square root of 5. Well, the square root and square reduces and leaves me with the radican, which is 5 in this case. 2 times 5 is 10. 10 minus 10 is 0. So the positive is true for sure. Let's plug in the negative. Well, what happens when I square the negative? It goes to positive, right? So, and the roots and the power reduces down and leaves me with the radican. So that is also a true solution. Check. Okay, moving on. Yay. Completing the square, there's a process we're going to do here. So we want to make sure it's written in descending order. What are we wanting to make sure is written descending order? Our quadratic. We're still working with quadratics. We want to make sure our leading coefficient, which we've been using a as the leading coefficient, is a +1. And then we're going to find what gives me the perfect square. And then we're going to express it into the equations of binomials. And then we're going to use the principle of square roots and solve for the variables. So let's just do that. Let me get my screen to slide over. All right. First things first. I want to go ahead and, I mean, a lot of people is going to say, oh, the coefficient of a, the leading coefficient in this case is a is 2, and it's not +1. Well, let's wait until we get it written into a specific form, okay? So what we want to do is we want our quadratic to look like this. Okay, so let's do that. Well, I notice my b is 3x, and it's by itself over here on the other side of the equal sign, and it's positive. So I'm going to subtract it to get it over here. If you want to do 2 steps in one, you go right ahead. And then I want my 1 isolated, my c value, which is -1. I want it isolated. So I can either divide everything out by this 2, my leading coefficient, or I can move and then divide. It doesn't matter. But I'm going to divide just because I know that a needs to be a +1 and it's a 2. So let's divide all parts by 2. And now I have x squared, a +1 coefficient on x squared. Perfect. And now I need, and of course, let's just do the extra step. 0 divided by 2 is 0. Okay, I need the c term, the constant, isolated, and it's a negative, so I want to add it. So now I have x squared minus 3/2 x. This box I put here, and if you notice I did it here too, this is where I'm going to determine what is my perfect square. Well, I'm going to use this formula of b divides 2 all squared. Okay, so let's do that. B divides 2 squared. What is my b? It's a -3/2, and I'm going to divide it by 2. I'm going to do an extra step. I noticed that I got a fraction in a fraction. So the basic math rule says we're going to keep the first term, change the operation to multiplication, flip the second. So now I got -3 times 1 is -3. I got 2 times 2 is 4, and let's square. The top square, -3 squared is 9, 4 squared is 16. Now I have my new c. It's +9/16. But what I do to one part, you have to do to the other side of the equal sign. You can't just do it to, you can't just plug in one part and do what you want to the other. It has to be consistent. Now that I've done that, I want to clean up this equal to side before I write this as this. And then I want to write it as this. That's our next step, right? So let's talk about it. Over here, I have, and I'm going to write it over here just to do my math on the side, 1/2 plus 9/16. In order to add this fraction, I need a common denominator. I notice 2 and 16 is my denominators. 16 is my common. So I'm going to multiply top and bottom by 8. That gives me 8 times 1 plus 9 all over 16. 8 plus 9 is 17. So this is going to be here. All right, so now what do I want to do? I want to find out what goes here. If my, and this is a really good point, my leading degree here is x squared, +1 x squared, then I know that each parenthesis is going to, let me change this, it's going to lead off with x. And a little helpful hint, right here before I square it, you notice we have a negative, right? So what does that tell me? It tells me we have a negative in both of these. Okay. Now, what is the perfect square? Well, square root of 9 is 3. Square root of 16 is 4. Is it not this here? 3/4. So sometimes this will help you. Well, if you notice that the binomials are identical, and there's 2 of them, so I can rewrite them where they're raised to the square root power. I'm going to clean up this other side, and now let's use square root method. All right. So I have this parentheses going on right here. Raised to the square is equal to this 17/16. I need to undo this power here. So what I'm going to do is take the square root of both sides. And remember, I get a plus or minus because it's an even root. So now that square rooted reduces down and leaves me with the radican. I got plus or minus, and I'm going to rewrite this as square root of 17 over square root of 16. 17 is prime, so it's not going to factor out. But however, square root of 16 does, and it gives me 4. So good so far, right? Let's finish up. Now I have x is equal to, well, what do I do to this negative 3/4? I need it by itself, or I need x by itself. So what I'm going to do is I'm going to add it, since it's a negative, to both sides. So I'm going to write it in the front, and then I'm going to have plus or minus square root of 17/4. So I have two answers. I have 3/4 plus square root of 17/4, right? And I have x is equal to 3/4 minus square root of 17/4. I'll leave it in exact form unless you are asked to put it in decimal, because square root of 17 doesn't give you an exact number. All right. Yay. So you can check your work. The next slide. So we're done with that. Now let's talk about quadratic formula. So solutions of ax squared plus bx plus c equals 0, a cannot equal 0 to have a quadratic. We have this quadratic formula. Yay. So there's a way of deriving this, and I look in my notes. I have this information, how this formula is actually derived. And if you'd like me to work it out, just let me know. Okay, so as long as it's written in standard form, a is not equal to 0. We know what each part is. We can plug it in and get our answer. This formula comes in handy when you cannot factor down, okay? And a lot of times we get imaginary numbers. So let's solve. We're going to find the exact solutions and the approximate solutions rounded to the thousands. So we're asked to find two answers here. So what we need to do is get this in descending order, and we need it written in standard form. And if I notice that this constant is isolated, it's by itself, I need it on this other side. Since it's positive, I want to subtract it. So now I have 3x squared plus 2x minus 7 is equal to 0. I know a is equal to 3, b is equal to 2, and c is equal to negative 7. And let's plug it into our quadratic formula. I got negative b plus or minus square root b squared minus 4 times ac. Whoops, my pen. Okay. All divided by 2a. Oops. Kind of need parentheses where the a's and c's are at. All right. Let's make sure the root goes across. There we go. Now let's plug in what I know. B is 2, A is 3, C is negative 7, A is 2. Oh, excuse me, A is 3. There we go. Clean my mess up. All right, so now let's solve. Now I'm going to do a little bit of math without the calculator first. So I got negative times positive 2. So I got a negative 2, right? Plus or minus. I got 2 squared is 4. I have negative 4 times 3, right? I got negative 4 times 3 is negative 12, right? And I got negative 12 times negative 7. So negative 12 times negative 7. And I'm doing it on the side, but it's positive 84. All divided by 2 times 3 is 6. Now, negative 2 plus or minus. And I wrote the approximation signs. We're not doing it approximate yet. So I got 4 plus 84, which is 88, all over 6. Now, sometimes it's not as obvious, but in this case here it is. So what I'm going to do is an extra step here. I got -2 plus or minus. I know 4 times 22 gives me 88. Doesn't always work out that way. So now I got -2 plus or minus. Square root of 4 is 2. Gives me a 22, all divided by 6. Now I'm going to rewrite it. I got -2 divided by 6 plus or minus 2 square root of 22 divided by 6. Now I'm going to divide this because it will reduce, right? I see that 2 goes into itself once and goes into 6 3 times. 2 goes into itself once and goes into 6 3 times. Okay. Now what do I have? My exact answer is going to be -1/3 plus or minus square root 22 over 3. That 3 will not factor into the root. Remember, it's only going to be the coefficient. So this is my exact. I'm going to rewrite it where I have to, oops, don't forget your negative sign. Where I have 2 answers. However, it did ask for approximately, oops. It did ask for approximation, rounded to the nearest thousandths. So now I'm going to put approximation sign, and I'm going to get a number for that one, and I'm going to do one here. So I'm going to use my calculator because that root is going to be yucky. And it gives me to the nearest thousandths 1.230. That's rounded to the nearest thousandths. Now let's go ahead and do the negative value of the root. And so I have -1/3 minus the square root of 22 over 3. And that gives me a -1.897. So now I've solved for the exact values and I solved for the approximation. And there we go. And you can check your work. Okay, so our next slide. Now let's talk about how do we know we have one real number or 2 different real number solutions, 2 imaginary number solutions, complex conjugates. You know, how do we know all that? Well, when we look at that formula we was just solving, this here, let me get my highlighter. This root right here, b minus 4ac, inside that root is my discriminant. What do I mean? That's going to determine if I'm going to have a real root, imaginary roots, or if I'm going to have one solution. How do I know this? Well, it states here that b squared minus 4ac, if that equals 0, what does that mean? That means I have a square root of 0. Then that's 0. So then I have -b over 2a. It's going to give me one real solution, right? Okay, so let's look at this one. If I have b squared minus 4ac and it's greater than 0, that tells me that this root is going to be a positive number. I can be left with the root. It could be like that, what we had a while ago, 2 square root of 22, could be square root of 17, but it's positive. It's a positive number here. Then that means I have 2 different real roots. So we had that a while ago. We had, I believe it's a negative plus square root of 22 over 3 and -1/3 minus square root of 22 over 3. Okay, so, you know, that right there, that's an example. Now, this next part. It says b squared minus 4ac is less than 0. Oh, what does that tell me? That tells me that whatever's inside this root has a negative value. And what do I know about an even root with a negative value, a negative radicand inside it? I have an imaginary number going on. So I'm going to have x is equal to, and that could be a plus or minus b, but it just depends on what b is, because anyways, y'all get the point. Then I'm going to have b over 2a, negative or positive b over 2a, plus or minus imaginary over 2a. Right. And these numbers may reduce. You kind of just get the point. So I'm going to have two imaginary solutions. So we have an example here. And it said, well, what happened? I thought we was working with quadratics, and that means that we should have a power of 2, not 4. Well, if we have something like that, it's telling us that if we rewrite it and use a substitution, and in this case here, they're using the number u in the replacement of substitution for x squared. And if I do that, then I'm going to have x squared raised to the square, right? But if I know that u is going to go in that place for x squared, then I can rewrite it as u squared minus 5u plus 4, and now I can factor it down. But the very last step, we have to plug back in the x squared for the u and solve. So we're going to end up with a possibility of 4 solutions. So let's do this. So I'm going to say, okay, I'm going to rewrite the x to the 4th to x squared raised to the square. I'm going to let u squared equal x squared. So when I do that, now I have u squared minus 5x, or 5u, excuse me, because we factored it out, right? And maybe I don't need to skip this step here. So let's write it. So now I have this. Oops. And my apologies, guys. I kind of talked a lot during this PowerPoint, so you may have to pause it, take a break, come back. So x squared raised to the square, we know it's x to the 4th. I said, okay, let's let u squared. So what I'm going to do is I'm going to let u squared equal, sorry. Let me backtrack. Did not make sense. 1 second. So look, we're human, right? So here we go. I'm going to let u equal x squared. And if I do that, let's rewrite it. That means I'm going to have this like this, which means I will have this, because I'm letting u go in the place of x squared, and I broke down x squared to raise to the square. Okay, I made it more doable. Now that I've done this, I'm going to factor this. So you can use the quadratic formula here, or we can ask ourselves the product of a times c, which is 1 times 4, that adds to give me negative 5. Well, let's do that. A times c is 1 times 4, and it's going to give me a product of 4. What is a product of 4? 1 times 4, 2 times 2. But we need it because the c is positive, so we know we're adding. B is negative 5, so the signs have to be both negatives, right? So I know if I said negative 1 plus negative 4, yeah, that gives me negative 5. So this is my new middle. Let's factor it. So I have u squared. Remember, bring down the first, bring down the last. And then let's replace the middle with negative 1. But don't forget we have this u, so 1 times that u minus 4 times u. All right, and now I'm going to split it in half, and let's factor it. This first side here, I notice I can factor a u out. So I'm going to divide both of them by u. U goes into U squared and leaves me with U. Positive U goes in negative U, leaves me in -1. Gotta be careful with my notation. My writing gets a little sloppy after I write a little while. Let's rewrite that. Okay, this other side, I'm gonna bring down the negative, and I notice I can factor 4 out as well, both of them. So I got -4 is dividing them both. Negative divides negative is positive. 4 goes into 4 is 1, leaves me with U. Negative goes into positive, leaves me in negative. 4 goes into 4 once, and voila. All right. Now I see that I have U times this parentheses, -4 times this parentheses. So I have this parentheses identical to this one. I can factor it out. When I factor it out, it leaves me with U -4. And now let's find the zeros. So I'm going to take U -1, set it equal to 0 and solve. U -4, set it equal to 0 and solve. Since this is a -1, let's add it to both sides. So now I got U is equal to 1. Let's add the 4 to both sides. So U is equal to +4. Now, what do I know? I know what U is equal to. But didn't we say U is equal to x squared? So I'm going to put x squared back in the place of my U. And now I'm going to undo the square by taking the square root. Remember, it's an even root, so I'm going to get a plus or minus. So I have x is equal to plus or minus, square root of 1 is just 1. I'm going to square root both sides on this one, plus or minus square root. X is equal to plus or minus square root of 4 is 2. So I have 4 solutions here. You can check your work, plug them in, make sure they're true solutions. Oops, let's come back. Oh, that's good. So yay. So now let's talk about applications. Some applied problems can be translated to quadratic equations. Example, magazine for closures. The numbers of both magazine launches and magazine closures have increased in recent years. The function, so they use the little m. They're calling this function little, this little m here, and which is good because magazines is m, and it's in respect to x. They told you that we have 34x squared minus 59x plus 81. Later on in this course, we'll learn how to create our own equation. Can be used to estimate the number of magazine closures after 2012. What year was the number of magazine closures in closures of 99? Okay, so the 99 is actually our go. We want to know what was the closure for that. So what I need to do is recognize that this is my mx. So what I'm going to do is rewrite this as 99 is equal to that 34x squared minus 59x plus 81. So I want 99 on the other side because I want it in standard form. So I'm going to subtract it from this side. And so now I have 0 is equal to 34x squared minus 59x minus 18. Okay, I'm going to go to the next slide just because I don't have a lot of room. And if you'll notice, voila, we're doing good. So now we acknowledge what A is 34, B is -59, C is -18. So I'm going to use the quadratic formula just because it's going to be a little messy. If you want to try to factor it without it, go for it. But it is going to be a little messy, so I'm going to save some time. And I'm going to plug in what I know. I got -b. B is -59 plus or minus square root. I'm going to put this b in parentheses because that negative sign gets squared. And we know what happens when you square a negative. It becomes positive. 4 times a is 34. 4 times c is -18. Bring my root over. And we're going to divide this all by 2 times a. So I'm going to type this in my calculator right quick. I'm going to clean it up too. So I have x is equal to negative times negative is positive. So I got positive 59 plus or minus. And inside that root, I got, and if you want to determine how many real roots or solutions we have, we can do it right here. We got negative 59 squared minus 4 times 34 times that negative 18. So let's do this. And what did I get? I got, wow, this here is a positive number. I got this number here. So I know I'm going to have some real solutions going on. It's still in the root, and we can check with our calculator to see if it reduces. I have 2 times that 34, we know is 68. So now let's figure this out. If I take the square root of the 59, 29, it does factor down. Square root of that is going to give me 77 over 68. Cool deal. That worked out great. So now I have 2 solutions here. I'm going to have 2 answers. I'm going to have 59 plus 77 divided by 68. I'm going to have 59 minus 77 divided by 68. So what is 59 plus 77 divided by 68? That gives me, 2. Nice. Over here, looks like a negative value. And it does give me, I'm going to write it in fraction form right quick. And let's write it in decimal. I'm going to round to the nearest tenths. Okay. All right. So since we are looking after the year 2012, we use the positive solution on here. Okay. So my answer is going to be 2 years here. And we can check our work. Fantastic.